Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 28, 2025, about 10 days ago. The big claim is that this paper delivers a two-model agentic system that reaches state-of-the-art in the open weights category on deep search benchmarks and deep research bench, while reliably extending tool calling beyond 20 calls when needed. The paper is titled Fathom-DeepResearch, Unlocking Long Horizon Information Retrieval and Synthesis for SLMs. And as we'll see later, the implications for long horizon reasoning are quite significant. In short, it pairs Fathom Search 4B and Fathom Synthesizer 4B with a new DUETQA dataset, a stable RAPO training recipe, and a steerable step-level reward, then shows strong generalization to tasks like HLE, AIME25, GPQA Diamond, and MEDQA. Also, the authors shared a GitHub repo with everything to run Fathom-DeepResearch end-to-end. You'll find the 4B search and synthesizer models wired up with agents, a web search tools server, setup and inference scripts, evaluation datasets and runners, prompts, serving configs, and clear examples for single question and multi-GPU evaluation. On Hugging Face, you'll find two open 4 billion parameter models, Fathom Search and Fathom Synthesizer, with files, chat templates, plus step-by-step SGLANG launch and inference examples. Alright, Figure 1 shows head-to-head results that demonstrate the search model tops open weight systems and nears closed models. The left panel reports WebWalker accuracy, where the model is essentially tied with the leader at about 50. The right panel reports simple QA, where the model lands at 90, trailing only the biggest closed models. The takeaway is that strong, long-horizon search behavior translates across two very different benchmarks, which signals robust generalization rather than dataset luck. Alright, Figure 2 shows the end-to-end pipeline that turns a research question into a citation-dense report. On the left, Fathom Search 4B performs multi-turn tool interaction guided by RAPO and step-level rewards, so search remains stable and efficient. The center box captures the search trace, which is the ordered record of tool calls and findings. On the right, Fathom Synthesizer 4B follows a plan, then write protocol, meaning it drafts a plan before writing the final report. Well, Figure 2 outlined the pipeline. Table 1 now shows how the search model stacks up across deep search and general reasoning benchmarks. The headline is that the Stage 2 policy leads open weights systems, which signals stable long-horizon tool use rather than shortcutting. On simple QA, it reaches about 90, while WebWalker lands near 50. The shaded bottom rows highlight Stage 1 versus Stage 2, and the gains appear across most columns because reinforcement learning and the step-level reward curb redundancy and reward real exploration. So, while Table 1 highlighted task accuracy, Table 2 assesses end-to-end report quality on deep research bench. This table compares open and closed agents using two metrics: race, which scores completeness and readability, and fact, which measures citation precision. The open system leads its category on race and maintains strong fact, landing close to closed tools that sit near 41 overall. The takeaway is credible reports with accurate citations. So Table 2 compares closed and open agents on deep research bench and highlights that the open system leads its category on race while keeping competitive fact. The table reports overall around 45, which matches or exceeds other open entries because the search policy yields comprehensive, readable reports. The fact columns show strong citation accuracy and effective citation count, with about 38 effective citations that indicate sustained evidence use. Wrapping up, two takeaways stand out. The 4 billion parameter duo, plus DUETQA, RAPO, and a steerable step-level reward delivers stable long-horizon search beyond 20 calls, and the synthesized reports stay readable and well-cited. The broader implication is practical, controllable research agents at small scale. Thanks for listening. I am Alex.